Let's see what happens when we try solving the localization problem relying only on odometry calculation. Although this is perfectly feasible, using only odometry for robot localization has several problems, and here there is a statement that you should always remember. Regardless of the sensor that you are using, their resolution, their quality or cost, and regardless of how sophisticated the sensor fusion algorithm that you implemented for the odometry calculation is, it will always be affected by intrinsic errors that tend to diverge, so that tend to increase over time. Namely, any odometry calculation algorithm will always be affected by errors that tend to grow over time. The more the robot moves, the greater this error becomes. Let me give you an example. Let's analyze some of the most commonly used odometry systems. For example, let's start by considering the wheel odometry. This odometry system, although very simple and expensive to implement, can be subject to errors that can produce incorrect estimates of the robot position or velocity. Let's see how this method is affected by a very tiny error in the estimation of the radius of the robot wheels. Let's assume that after a long and tedious measurement process, we have calculated that the radius of each wheels of the robot is 3 cm. However, after a few months, due to the wheel wear, the actual radius of the wheel is not 3 cm but is 2.9 cm. Nothing to worry about it, you might think. After all, it's just a tiny 1 mm error. Or is it? As the robot moves, exactly when the wheels have completed 1000 full rotation, let's try to estimate the robot's position based on the wheel's odometry. The odometry calculation, which assumes that the wheels have a radius of 3 cm, estimates that the robot has traveled almost 188 meters. In reality, since the robot's wheels have a slightly smaller radius, so we said 2.9 cm, the actual position of the robot, so the robot will actually have traveled few meters, only 182. A whopping 6 meters error in our localization system. In a domestic environment, this is equivalent for our robot to think that it is in one room, then actually it is in another room. Another source of error that might affect the odometry calculation is due to the assumption that we have made that the robot's wheels are rotating without slipping. However, this is not always true. Very often, due to imperfections in the floor or the robot passing through highly slippery areas, the robot's wheels may slip. This means that the wheels are rotating, so the encoders are measuring this rotation of the wheels, but actually the robot is not moving, so the wheel is not producing the expected movement of the robot due to the lack of traction between the wheel and the ground. Okay, fair enough. This is a typical wheel odometry issue. Let's try with another one.